All right, we're going to solve some polynomial equations. And it says to do it symbolically or graphically. And that just depends on which method is easier. So I have some examples here that I'd like to work through. And whenever you have a cubic polynomial with 4 terms like I have here equal to 0, you're going to try and factor that, and the hint for you is you want to factor by grouping. If you can't factor by grouping, then I would, in this case, use my graphing calculator. But I think this is going to work if I factor by grouping. So let me show you that method. So what you do is you put it in descending order. So first I have x cubed, then my quadratic term right here, my linear term, and my constant term. So it's in descending order, and I want to group these 2 together and then group these 2 together and, so that I can factor. It's obvious here that both terms have x squared, so I can pull out an x squared, and then I'm left with x minus 3. And here, notice that both terms have 25 in them. So I'm going to pull out a 25, but I actually want to pull out the negative as well. And the reason is because I have a negative here and a plus here. So I want to be able to have x minus 3, because factoring by grouping only works if after you do the first factoring of the groups that you get identical factors here. If these aren't identical, then factoring by grouping is not going to work. But so that's why I pulled out the negative here as well, so that these would be identical. Because if I didn't pull out the negative, this would have been a plus. And anyway, so I've got my 2 terms now with the common factor of x minus 3. Since this is common to both, I can pull it out. And what's left is x squared minus 25. And then I want to factor some more. So I'm going to get x minus 3, x. This is the difference of squares. So that would become x plus 5 times x minus 5. And now I can see that the zeros of this polynomial, I'm looking for the zeros because I'm wondering when is it equal to 0, are 3, -5, and 5. So those are the solutions. X equals 3, 5, and -5. Those are the solutions to my equation, polynomial equation. All right, now, if I look at this one, this is also cubic, but it doesn't have 4 terms like this one up here, so I can't factor by grouping. And in fact, looking at this, I really don't know how to factor this. So in this case, when you're stumped as to how to factor, that's when you're going to turn to your graphing calculator, and you're going to try to solve the equation using your graphing calculator. So I've already entered in the function. If you look here, I put in x cubed. I don't know if you can see that. I put in x cubed minus 12x minus 16 into my y equal function, and then I select graph, and you can see that I have 2 intercepts, x-intercepts. One right here, and that has a turning point that touches the graph. So that particular 0 there at -2 has multiplicity 2, and then the other 0 passes through, so it has multiplicity 1. So it's going to be the turning point. If we have 1 turning point, plus we have another intercept, that's going to be making up for that degree 3 polynomial there. All right, so now let me just draw this picture here for you that I got from my graphing calculator. It looks like it's the zeros are at -2, and at 5, or is it 4? I'm sorry, it's 4. 1, 2, 3, 4. Okay. So because it's multiplicity 2, what that means is that when I factor this, I'm going to get x plus 2 squared, because the turning point, it touches the x-axis at that point and then bounces back. So I know it's going to have even multiplicity. And that just means, and it can't have more, it can't be 4, it has to be 2, because our degree is 3. So the multiplicity adds up to your degree. This one is x minus 4, because it has 4 as an x-intercept, and it passes through, it's gonna have odd multiplicity, and that's as high as we can go, because the degree of the polynomial is 3. So now, looking at this, we know that x equals minus 2, x equals 4 are the solutions to this problem. Now, looking at this next one here, we have the difference of squares, so that's going to be x plus 3 times x minus 3 equals 0. And so x is -3 and 3 are the solutions. And here I can see that both have a common factor of x. I can pull that out, and I see that I can factor this as the difference of squares. So it's x plus 1 times x minus 1. And I get x equals 0, minus 1, and 1. So generally, it's easier to factor, but if you can't see how to factor a polynomial, then by all means use your graphing calculator to do it graphically instead of symbolically.